What's up everyone? I am back with another repair video. This is going to be something a bit different than what I've done in the past, or what, if you follow my channel, what you might be used to seeing. This is a Pioneer stereo receiver model SX-450. This is actually a friend of mine's. He asked me to take a look at it, knowing where my interests lie, and it's doing a interesting symptom. It has an interesting symptom, and unfortunately I can't show you guys here because I don't have speakers. I never repaired one of these before. There are plenty of guys out there who specialize in repairing this, so this video is definitely not going to be a guide on how to repair these. And that's I hope for people that watch my channel, I don't try to pass off any of my videos as a guide. I try to give it a feel that you guys are learning along with me, because that's what I'm doing. I learn through repair. I'm self-taught. There's still things I don't know. So just, if you're looking for a video on how to repair stereo receivers, this is not it. So just putting that out there. But anyway, yeah, so what is this thing doing? Well, it's having some issues with the volume dropping out when you change the balance from one side to the other. The volume will drop out. It does this when you've got it hooked up to a vinyl record player. It'll do that for the auxiliary setting. It doesn't seem like it's something specific to a certain. It's affecting all of the outputs, I guess you would say. So with that in mind, I think what we can do is take this thing apart, have a look inside. It could be something as simple as just a scratchy pot, or something more complex, and we're going to try and figure that out. So let's dive right in here and take this thing apart. Alright, so we've got the receiver opened up here, fairly easy. It just had these two panels, left and right, a few screws, and then of course the top panel. But a lot going on here, a lot of electronic engineering concepts all within this one device, which makes them pretty cool to work on. I'm looking forward to learning a lot from this, potentially. But let's just go over what's going on as far as the circuitry. So we've got what looks like two boards, PCBs. You've got one on the left, which is your power supply and your power amplifier, and then on the right, this is the RF circuitry, radio frequency circuitry, for the AM and FM receiver. So let's start with this side, the right side. And so again, this thing is capable of AM and FM radio, and so you've got two different circuits for that. All right, so there's also you got three integrated circuits. You can see them right here, these ICs. These are proprietary ICs, I believe, made by either Hitachi or Pioneer, and they are very important to this instrument's function. You've got an HA1138. So let's just start with the AM circuit. That is an AM tuner IC, which has a lot of functions all in one. You've got well, let's just start with this antenna, right? So this is the AM antenna, and so the input to that antenna is going basically right to that IC. I'm not even sure if I'm pointing at the correct one. No, it's this guy right here, actually. That's HA1138. So the antenna input is going there. There's a mixer in there. There's filtering in there. The IF, intermediate frequency amplifier, is in there. So you've got all this bundled up into one circuit IC that is giving you an audio frequency output. So that's pretty incredible. Now you've got this air variable capacitor. It's a 5-gang variable capacitor. You've also got these 5 tuning caps on top. Well, it looks like there might be one missing. Or 2 of these are for the AM tuner, then you've got 3 for the FM tuner. All right. Now, as far as the FM tuner goes, the mixer and the local oscillator are not built into an IC. So you've got this HA1137 down there. Let me get something to point at. So that's it down there, and that is taking that is an IF amplifier. So you have an external mixer, which I believe is somewhere in here, made of discrete components, it looks like, and then the local oscillator is also there as well, and that is being fed into that HA1137, and then the demodulator that circuitry is integrated into this IC, this HA1156. All right, so that's in summary the tuner circuit. And so then on the left side, this again is your power supply. So you can see, this big transformer, no switch mode power supply in here, obviously, being how old it is. This is the AC mains input, pretty much going directly to this transformer. And you've got a few different windings on the secondary side. You've got a winding that is providing roughly 8 volts to these lamps, okay, to light up the tuning display or dial. You've got another winding that is being used for the power amplifier, this multi-stage power amplifier, and that is it's a full wave rectified. It's center taps, so you can get positive 25 and minus 25 volts for the power amplifier. And then you have another winding that is being, I believe, it's half wave rectified, and that is being split down. That's being broken up into 2 voltage rails, both being regulated by 2 different Zener diodes. One of those rails is, well, you can see the Zener diodes. I'll show you those. That is one. You can see that says 35. I believe that's for the 37 volt rail. And then that is for the tone amp. And then you've got another Zener diode here that is providing roughly 14 volts for the tuner circuitry. You've got these 2 big filter caps. Those are being used for the power amplifier. You've got your big, I don't know if big is the right word, but definitely these transistors here that are on this heatsink that are part of the final stage of the power amplifier. But yeah, so that's a summary of what's going on inside. I don't know how much we'll get to troubleshoot any of this. Given the symptom that we're having, it could just be as simple as a dirty pot, but we'll see. All right, so I've done a few things. I cleaned all of the pots, and I just used some contact cleaner, deoxit. Cleaned all the pots, sprayed some in the front, exercised them a lot, and then for some of these, you can hit them from the back too, just wherever you can get them. These snap action switches also, you can get in those with cleaner. These are notorious for getting dirty, so right in there you can get them. Yeah, just really hit these hard with contact cleaner, because it looks to me I know I didn't show you guys what actually was going on, but it looked like it could have easily been like a scratchy pot. So that's what I started with first. I there was a lot of excess contact cleaner, so I cleaned that up the best I could, and then let it dry for about a day or so, just because I couldn't work on it. So all of it dried up, and then I decided to start it up. Also brought in some speakers as well, just to kind of test things out, and I had it on for a bit. So I was just using the receiver, the FM AM receiver, to kind of check the volume, check for volume drop, and I really wasn't getting anything. Now I'm going a little bit further. So the first, well, the only test that the manual gives for the a procedure for the power amp section is the idle current. All right, and the instructions are a bit vague for someone who's never done this before, but it's my understanding that you're connecting an 8 ohm dummy load across the speaker terminal. So I've just got basically simulating two 8 ohm speakers. I've got 8 ohm resistors there that are well over 15 watts, which is the max for this amplifier. So I had those both hooked up to the speaker terminals. And then it says to connect a DC voltmeter between, depending on what channel you're testing. Left channel is 19 and 20, and we are getting 55, 56 millivolts. All right, so the manual says if you're reading less than 15 millivolts, you should cut the jumper lead. And what do they mean by that? Well, there are two jumper wires here and here, and I guess what they're saying is that you'll need to shorten it to get that voltage to increase. So that looks okay. We're above 15 millivolts, and we're going to check the other one. Okay, so now we are checking the other channel, and we are getting roughly 70 millivolts. Now, there's no spec saying that the two should be similar, so the only spec is it should be greater than 15 millivolts, and that's what we got. All right, so this isn't in the manual for this SX-450, and there is no specification for it, but you know, again, I'm not too familiar with repairing stereo receivers or amplifiers, but I hear in some of my initial searches on trying to get some experience with them, what to look for, I saw a lot about DC offset, okay? And, you know, that an ideal settings, an ideal amplifier will have zero DC offset. And what is acceptable for DC offset, and that was actually tricky to find concrete info on. I got a lot of different results for that. But it seems like 50 millivolts plus or minus or less is okay, and anything greater than that is probably not. And so I decided to check for that, and the way you do that, again, this is what I found, is you have no inputs to your amplifier disconnected, volume set to a minimum. Not sure if that's completely necessary. Bass, treble, centered, balance centered, and then you check out the speaker terminals with a DC meter that has a, you know, can probably a good idea that it can read in millivolts, and that's what you do for the left and right speakers. And sure enough, for the left speaker, we are at 54, 55 millivolts, which apparently isn't good. The right one, I'll show you guys that in a minute, was much lower. It was around like 15 millivolts. So, yeah, this could be an issue. I don't know if this would be something that would be discernible to the ear, but it could be an issue, it could not be. I don't know if it's acceptable for these. Um, but might be worth investigating further, maybe looking a bit more closely at some component level, testing. But yeah, and here you go. This is just the right speaker at 14 roughly millivolts. So that one's looking good. All right, so I figured I'd check the voltage rails, the power rails. I had mentioned this earlier. There's a 14 volt rail for the tuner circuit, the stereo receiver, or the receiver, I'm sorry, and there is a 36 volt, 35 volt rail for the tone amplifier, and then you've got 25 and negative 25 for the power amplifier. And so I looked at all those rails with the multimeter and everything looked normal, but I'd like to check it on the scope, check it AC coupled to check for any ripple. Alright, so this is the 14 volt rail, I believe. Yes, it's the 14 volt rail, and you can see that there is practically no ripple. We're at 200 millivolts per division, and it looks very clean. And the same goes for the 36 volt rail, again, looking very clean. Now, this is the negative 25 volt rail. Now look at that. That is a lot of ripple. I mean, I guess it's not terrible. It's 500 millivolts. I mean, there's no spec for this, obviously, with, something like this, a piece of equipment like this. But, compared to the other voltage rails, it's pretty poor. And so here's the 25 volt rail, and same thing. Alright, so let's take a look at the schematic. So here you have your full wave rectifier right here, and center tapped, and now that's your negative 25 volt and your positive 25 volts. This is where we were checking. This is what's filtering those rails. Just these two 4700 microfarad electrolytic capacitors. So, these are the caps right there. I don't know. I'd be surprised if these were bad, but we're gonna have to, remove the bottom cover to take a closer look at these, check them in circuit with the ESR meter. We could take them out of circuit as well to get a more accurate check. But something tells me that these are probably going to be fine, and this is just intrinsic of the unit. So it may be a red herring. But what I'd like to do is to do more component level troubleshooting. I would like to, I'm going to need to take that cover off, the bottom plate off. So we'll start doing that next. Alright, y'all, so we're going to check the ESR of those two big filter caps for the 25 and negative 25 volt rails. So I've got my LCR meter set to a frequency of 100 kilohertz, which is what you would set it to check for ESR. Let's see, here we go. So here's one of them. And you can see it's very low. This is the other one, and it's also very low. We should be able to accurately measure the capacitance of these in circuit. So we're gonna bring this frequency, the test frequency down, and let's check one of them. So we're getting 4.5 microfarad, millifarad, which is 4,500 microfarad. The cap is a 4,700 microfarad cap, so that's good. And we'll do the other one. And we're measuring 4,300 microfarad. That's for both of them. 10% tolerance within. I'm not worried about these two caps, so I suspect that ripple that we saw is intrinsic of this device. It doesn't give a spec for it either. So I think what would be fun to do is inject a sine wave to one of the inputs and check it on the output, and see how it looks. So why don't we give that a try next? Alright, so we've got a pulse generator or function generator, signal generator. We've got it hooked up to the auxiliary input. So from a BNC that connects to these two test leads on the back of the board, it's connected to the right RCA input. And then from there, we've got the oscilloscope connected to an 8 ohm dummy load. I'm sorry, we are connected to the left channel, my bad. We are connected at the left here, and then the left speaker here. Alright? Okay, so, and we're connected to the oscilloscope. Now, as far as what amplitude to set the signal generator to, I was using the manual for the stereo amplifier, and so you can see here the input sensitivity is 150 millivolts. It is my understanding that that is the minimum amplitude needed to drive the speakers. So it's not the max, it's the minimum. So I guess we're starting at the minimum. And 1 kilohertz is the frequency. Alright, so currently the function generator is on, output is enabled, and sorry my camera's not really focusing right now, but let's take a look. Volume is currently turned all the way counterclockwise, so let's turn it up, see what happens. Okay, that's at maximum. All right, so we are getting a very pretty sine wave. That looks very good. I'm bringing it back down. Okay, and that's happening because the trigger level is set higher, so it's not able to trigger on the signal, but that looks really good. So let's try the right channel next. Alright, so I just wanted to share this with you guys real quick. So remember when we were measuring the DC offset? So this is basically checking the DC offset on a scope. Right now we are on the right channel. Alright, we started on the left in the previous segment I recorded. So this is actually what we're going to be checking next. And if you remember, I believe it was the right channel that had a DC offset checked with the multimeter of roughly yeah, like 13 millivolts. And you can see that's what we're pretty much getting right there at the bottom of the screen. But watch what happens when I switch to the left, which is actually what we just checked. Look at that. So you can see that our DC offset is much greater. For an ideal amplifier, which should be sitting right at ground, which is right up here. And you can see now it's jumped up to, 40, 50, 50 millivolts practically. But we just looked at this channel with that's what we injected a signal into, and we got a really nice looking sine wave. Let's see how the right channel looks. Alright, so we're going to be checking the right channel now. I'm increasing the volume right now. Oh. So, yeah, that looks pretty good. Alright, so a bit of a change of scenery. I'm now at home working on this, and a couple things that I've noticed. So right now I have the unit in auxiliary mode, and we have two probes on the left and right channels. I also have the signal generator connected to both the left and right input, the auxiliary inputs. Just injecting right now a roughly 500 hertz tone. I mean, it's disabled currently, but I just want you to take a look. So we turn that on. You can see both of these signals are overlapping perfectly almost in their amplitude. We lower that a little bit. Okay, and you do see that I have the channels offset a bit, because remember, their DC offset between the two channels is different. I forget. So right now, the left one, I believe, is channel 1, and we're the left channel, and its offset was, I think, 50 millivolts roughly, and the right was like -10, -12 millivolts. So that's why they're ground for both channels is offset, and you still have them lining up perfectly. So that explains that, but the amplitudes for both of them are pretty much the same. That is not the case when I have the unit in the phono mode, and we can take a look at that in a second. But I just wanted to show that to you guys. Just changing the frequency on the function generator. But yeah, so why is that? Well, it could be due to this EQ amplifier. That is the only difference between the auxiliary input and the phono input. You can see the auxiliary bypasses that equalizer amplifier, and the phono does not. So there might be something going on there, or at least that's worth taking a look at to see why there's a difference in power between the two channels. So I'm going to show you guys that in a sec. Alright, so now we are probing, we're injecting a signal into the phono input for both left and right. I know that's a little bit annoying, but I'm going to turn it up a bit so just so you can see the difference in the peak of both of these left and right channels. So you can see that there. See that difference? And if we becomes a bit separate them as well. You can just see channel 1, which I believe is the left one, has a smaller amplitude. But you can see visually that there is a difference that isn't there on the auxiliary. And it seems small, but I think it's worth checking out. So let's take a closer look at that circuit, make sure everything is looking good. Alright, so I'm kind of going through the equalizer amplifier circuit for the phono input. I'm probing both left and right portions of the amplifier. Everything was looking great. And by the way, we're AC coupled here to follow the signal through from the function generator. This is the circuit for the equalizer amplifier. Okay, and so, you know, here's your left and here's your right, and basically just been following the signal. This is, you know, we've got the function, we're inputting a sine wave of, you know, I've been adjusting the frequency here and there because it gets annoying to listen to it at one. Well, it gets annoying to listen to it all together, but anyway, you know, we've been following it through all the way to Q201 and Q202. Everything looked good here. Followed it through the emitter. R219, this 1K resistor here and here, things look good. But then after this R221 and R222, right at this point, that's when the signal starts to differ. We can see that a loss in response in the left channel versus the right. It's minor, but that's, I think, where things start to shift a bit, and we can look at that now on the scope. So you can see right there that difference. I'm actually using the math function of subtracting both signals, and you can see the slight difference. You know, it's hard to make out, but it's there. Yep. Okay. So, yeah, see. So, what could it be? It could be, you know, it's hard to say at this point. You know, I'll check some of these passive components in this area. I could be chasing a red herring. This could be totally normal, but, you know, we'll have to take a look. But it looks like we're kind of zeroing in potentially on a section where maybe things are going wrong. Alright, so I did find a capacitor, a tantalum cap that, you know, it could be on its way out. I mean, that's ESR is a bit high, at least compared to the other tantalum. This is an 0.47 microfarad 35 volt tantalum, and you can see the ESR is at 32 ohms, and this is at 100 kilohertz. So it just didn't look good compared to the other. This is in the left channel, and I can show you which one it is. So okay, so this is the left channel. This is C317. This cap is right on the output of the equalizer amplifier, and then that goes on to the preamp. Alright, so you can see, so that could have potentially been the culprit. I mean, I measured all these other electrolytics in circuit. You can measure these in circuit fairly well, both for ESR and for capacitance, and everything else looks pretty good. I do have a replacement, and we can look at that just to compare it. Alright, so this is the new one, and you can see, I mean, it's a pretty big difference. The ESR is a lot lower, even the capacitance at 100 kilohertz is much greater. So could it be the issue? Maybe. We'll find out soon enough. I'm going to pop this in and we'll measure both channels again, inject a signal, and see if there's any difference. Alright, so replacing that capacitor did not fix the issue. I mean, it does look better actually. It looks a little better. That actually does look a lot better. Yeah. Okay. Well, that's good. Okay, so I did find a few more tantalum caps that were testing a bit questionable. You see those yellow ones in there in the power amplifier section. The originals were, you know, again, the ESR was a bit high, and also the capacitance at, you know, 100 kilohertz testing frequency was lower than some of the new ones I have. So I just put those in. I tested every single electrolytic and tantalum cap in this thing, and everything else in this board is in the unit is testing fine. And I know it's pretty routine to just recap the entire thing when it comes to things like this. And I did ask my friend if that's something he wants to do, and I'll see what he says. But you know, the tantalums I feel are more important just because they tend to fail short, and that can cause some significant issues depending on where they are located. But you know, I'm not a big fan of just recapping things for the hell of it. So based on what he wants, that's what I'll do. Also, really clean the other side. It's a single-sided board at least. So all the solder flux, there was a ton of flux residue all over the board, and I cleaned all that up. You know, I have seen what can happen sometimes with flux residue left on boards during the fabrication process is it can cause what's known as dendrites to form, and that is when this flux acts as a substrate for charged ions to fall on, and they form these conductive bridges from one point on the board to another, and they create a channel by which electric current can flow where it shouldn't, and that can cause issues. So it's always amazing to me when I see boards that are just left with a whole ton of flux residue on them, and so I just want to play it safe and clean all that up, especially considering how old this thing is. So did that the best I could as well. So yeah, that's kind of where we're at. Again, after replacing all those caps and cleaning everything up, I did do another check of the idle current. It's about 70 millivolts for the left channel, 50 millivolts for the right. So that's fine per the manual, as long as it's above 15 millivolts. And then still the DC offset is negative 50 for the left channel, and negative 10, I believe, for the right. Which, for the left, that's not. Ask different people, they'll say different things. But I think, being that this is a lower end unit, this is probably the best it's going to get. You don't really have much ability to make that adjustment, or at least bias the transistors. You know, you have that jumper lead there that you can shorten, so you don't have a lot of control over any of that. So I and it sounds great. I did test it out. I tested out all the inputs, and it really sounds great. So I think it's good to go. I did want to ask my friend. So one thing I did notice is the FM tuner is a little bit off. It may need an alignment, so I asked if that's something he wants to do as well. So might fit that in as well. All right, we are back in the electronics lab, back at work. So I spoke with my friend about, what he wants to do with this. We can recap the entire thing. We can also do an AM and FM alignment on it, because the power amplifier is looking good. I mean, I can't listen to show you guys me listening to records on here due to copyright issues, but I was listening to some records at home and it sounds really good. I'm not seeing that volume drop anymore that we both saw, but anyway. So he said no to the recapping, which that's fine, but he said yes to an AM and FM alignment. Now, I probably should have looked at what equipment I had before agreeing to, giving that option, because I realized afterwards that I don't have the best equipment to do the AM alignment. I have this signal generator, which you guys have seen before, which has a range of 10 to 520 megahertz. That'll work great for the FM alignment, but it can't do the AM alignment. And I was thinking of almost abandoning doing it. I mean, not many people listen to AM anymore, but then I started looking at what I have as far as equipment. I looked up at this guy, this ICO 315 for a second. But that guy needs some work. It's not putting out a very nice waveform, and it just that's another project, so can't use that. But we used this a few times throughout this video. This 8116A is a 50 megahertz pulse generator, function generator. This operates within the range we need. The problem is it's not geared towards RF. It's not like an RF signal generator. It doesn't have AM, FM modulation in the sense that it's like at, the flip of a switch. This guy is very straightforward, right? There it is right there. Really easy to use. You adjust from 0 to 100 using this knob here. Here's your, you have two selections for your internal modulation. That would have worked great if it had a greater range, but unfortunately it doesn't. But you can do AM and FM modulation using this guy. And the way you do that is via this control input here. Alright? And you can see here these options for modulation. You have FM, AM, PWM, VCO. So you can do it. Now, right now I'm just checking the signal on the scope, so I've got this output going to my scope, and then this guy is the control input that is going to another function generator that I have, this WaveTech, what is this, 275. I think this was like the first function generator I ever got. Barely knew what they did, so I don't use it all that often, and the interface is really, it's not the most user-friendly, so it rarely gets used, but here it is. This is what we're using to get our modulation signal. And so the SX-450, this is the setup, set for 400 hertz at 100 dB or negative 100 dB and 30% modulation. So we're looking to inject a 400 hertz signal. The first set point we're going to use is 600 kilohertz, so we want to modulate with 400 hertz at 30% modulation. Now, the way that this AM modulation is described in the HP manual is output signal amplitude can be modulated from 0 to 100% using a voltage in the range of plus or minus 2.5 volts. So to me, that is the way I interpreted that is a signal with an amplitude of 2.5 volts from our wave tech is going to give us 100% modulation, but we only want 30%. So what's 30% of 2.5? 750 millivolts. So that is what I'm injecting to get that 30%. And sure enough, there's our signal. Now that looks like 30% modulation to me. You know, if it was 100%, for example, you know, we would have really steep valleys, and they would come to a point, and we're not getting that. So that looks pretty good. So I think we are good to go. Now, there is something else that is a problem. This guy can't attenuate that low. It can't produce a low enough signal, so we need to attenuate it further, and that's what I'm going to use this guy for. So I'm basically starting at roughly 300 millivolts RMS. That's roughly 0 dB, and we'll just attenuate down to negative 100 dB and then apply that to our antenna, AM antenna. So that's the plan. We'll see how it goes, and yeah, we'll give this a try. Alright, so let's do the AM alignment. So this starts out with a 600 kilohertz signal that is 30% modulated, 400 hertz. At negative 100 dB. We had to bring that up a little bit because to get a clear signal, and yeah, so we're starting at 600 kilohertz on the dial, and the signal, the HP pulse generator, and adjusting T6 for maximum indication. Alright, so now we're at 14. I'm going to change the dial to 14. And it is asking us to adjust TC4. Okay, that's good. Again, set AM signal indication to point A and adjust the antenna bar cord. Signal to point C. Alright, so we are back at 1400 kilohertz, and now it wants us to adjust TC5 for maximum indication. did manage to find an AM radio station. This is actually 1060 KYW, and it's accurate. So it did work. It's just because we're in this building, it gets horrible cell reception. It gets so it doesn't surprise me that this is the only station I'm able to grab on here, but it's proof that the AM tuner is working fine. And yeah, I wonder if you can guess who that is. Okay, so we got a lot going on here. Not the best setup for sure, but look, you know, I wish this area was a bit more conducive to strictly just electronics work, but unfortunately that does not make up the biggest majority of what I do at my job, as much as I would like it to. But anyway, let's take a look at the procedure first, alright? Starting with connecting a 300 ohm dummy amp antenna. I'm using a 300 ohm power resistor on the FM antenna inputs, and you're going to connect a signal generator through that. It's asking for 400 hertz at 100 dB, negative 100 dB, and 100% modulation. And the first set point is going to be 90 megahertz. All right. Now, as I had mentioned earlier, my setup is not the best, so I did a video on this guy to fix the knob, the range knob, and it works, but it definitely needs a calibration. That is where 90 is according to this counter, which I had it connected earlier, so that's where we're at there. Because if I'm gonna do this alignment, I want to make sure that this thing is accurate. So that's what we have to do as well. Now, it says to set to a negative 100 dB. That's attenuated too much for the radio to pick up this signal clearly enough. So we're gonna bring this down to 70, negative 70, and you could start hearing it a bit, but it still doesn't poke through all the noise. Now look at that. That is what, at least, you know, as far as I'm aware, that is kind of what we're looking for. Now if I move this, the tuning dial a bit, and you can kind of see how the signal changes. Kind of see how noise starts showing up at the top, and then, you know, disappears completely. But that's where you want it. We can keep going a little bit further. The signal gets down because also, according to this manual, you're setting it for maximum amplitude, and so that's maximum amplitude. But you can also see that we've got really nice clean peaks, nice rounded off peaks at the, you know, the positive portion of the wave and the negative portion. All right, that's the 400 hertz modulation coming through. That looks good. And so right now the tuner is not set directly at 90, so I'm gonna have to bring that back to 90, and then tuning one of the coils, I forget which, we'll go back to the manual to check, we'll bring it to this peak. That's that's where we want it. All right, so I just wanted to give you that brief overview first, and I'm gonna set up the camera so you guys will have a view of the scope as we make adjustments. All right, so like I said, starting with the FM alignment, currently have the dial set to 90 on the receiver, and we have 90 megahertz going in, modulated signal to the antenna. And so now we need to adjust T3, that FM coil, to basically get the signal that I showed you guys earlier. Okay, so that looks good. It's basically what we want. Adjust T5 for center of scale indication on the AM/FM meter. So I'm having trouble getting it to center on the AM/FM meter. So we might have to just revisit that later. Okay, so next it says set FM signal generator for 9 dB output and adjust T1 and T2 for maximum indication. Alright, one of those coils is in really bad shape, really brittle, so I don't want to mess with it too much. Now the next step is set FM signal generator to 106. So we'll do that. And the dial to 106 megahertz as well. Alright, now we're going to be doing step 8. Signal generator set to 106. So is the receiver. Adjust TC3 and then TC1 and TC2 for maximum indication. I believe TC3 is very finicky. Yeah, see? I'm barely touching it. I think that's where we want it. Yeah, I think that's about as good as I'm going to get it, and then we'll do TC1 and TC2. Oh, there you go. So that's TC1. That's TC2. So I think that's as good as that's going to get. Or repeat steps 8 through 11. We just did 8 through 11. Oh, I'm sorry. No, it says then go back to point A. So let's go back to 90 megahertz. I'm sorry, and see if any changes occurred. All right. So we're back at 90 on the signal generator, 90 on the receiver. It does look like there's been a slight change. You know, the peaks aren't looking as clean, so we'll adjust. We'll adjust T3 for that purpose. Okay, so that looks good. All right, so we are back at 106. Alright, so that alignment is done. After the alignment, this is basically 94.1. You get the Phillies playing. You know.
Hours of $6,000, which is the largest child tax credit that we have given.
It's NPR. It's not perfect, but you know, that's the best that I think I'm gonna be able to get it. You know, that's 98.1. Yeah. Q102. So yeah, I mean, that's pretty good. It sounds great. All right. Well, that's a wrap on this guy. Very hard to get reception in here, even after. Yeah. So, but yeah. Again, you know, we just finished doing the AM FM alignment. We troubleshooted the power amplifier, cleaned the pots, checked the idle current, checked the DC offset. You know, we're kind of potentially going down a rabbit hole with that one channel when it was in the phono, one channel seeming to have lower output than the other, and so we kind of looked through the equalizer amplifier, and changed a few tantalum caps. But all in all, this thing seems to be in great shape. It's a shame that the varnish or whatever, this fake wood, is starting to peel off there. True restoration on this, I guess you could, but that's really not my wheelhouse. Just trying to help my friend out by looking this thing over, and it was a lot of fun because I don't really work on these. Definitely not something I work on often at all. I've done a radio alignment before on an old tube radio. That was my first introduction. I really liked it. So this is probably the second one I've done. But yeah, it's really interesting stuff. I really enjoy it. But yeah, this is all ready to be delivered back to its home, back to its owner. And I hope you guys found this video interesting. You know, again, like, this is not a how-to video by any means. This is just me trying to take you guys along on how I would attempt to repair something. That's usually what these videos are. So, you know, I apologize if you were looking for something a bit more, you know, someone with a bit more expertise. But that stuff is out there. There's videos out here for this exact make and model, you know, so that's there. All right. Well, that's it for me. I'll catch you guys at the next repair.